your data sheets are lying to you. We're going to go through a data sheet here where an engineer did not read it properly, and it caused some major issues with their particular product down the line. So this type of thing is not limited to this data sheet. This happens all the time in data sheets. So I want you to pay attention so this issue does not happen to you. So this is a LED display driver here. All it does is drive some 7-segment displays. What I want you to do now is look at this V plus pin. Where's the bypass cap? Where is it? Okay, it's on the first page. So, this is just gives a lay of the land on the first page, not goes into detail on every little thing. So I'll give them a pass. Now let's go to the pin descriptions down here. Pin descriptions. Oh, okay. V plus, positive supply voltage, connect to plus 5 volt. Also no mention of a bypass cap. But it's a pin description. Sometimes they will go into that detail. Sometimes they won't. So I'll give them a pass for not doing that here. Okay, now what I want to do is look at the pictures. So we go all the way down here. Okay, we have our IC in question. They connect it to something else that the company makes. Only one bypass cap or 2 ICs. That's a little weird. And it's right in the middle. So what belongs to what? Okay, all right, don't quite like that. But if we go to the next page, look, 0.1 microfarads, sweet. So this is what that designer did. They looked at the picture and they did what the picture said. And it worked for a while until there were supply issues on the 7-segment LEDs. So they had to be switched over, and that's when the failures started to happen. And it wasn't quick failures, it was the customer got it, and then it eventually, segments would burn out. So very not ideal, especially for a product like this that's in the customer's face and easily seen. So we don't like that. Okay, so now what if we go look at what the datasheet actually says with words, not pictures? So I want to look at this line here. To minimize power supply ripple due to the peak digit driver currents, connect a 10 microfarad electrolytic and a 0.1 microfarad ceramic capacitor between the V plus and ground as close to the device as possible. 10 microfarad, you say? That's not in the picture. That's not in the picture at all. What in the world? But once again, this type of thing happens in data sheets all the time. It so much so, I almost don't even, I look at the pictures for a lay of the land type of thing. But as far as actual implementation, I am always in the text reading it. So this product is actually pretty old. So as an engineer, it's up to you to decide whether these data sheets are full of crap or not. In this case, okay, yeah, I'll do the 10, but it's not going to be an electrolytic. It's going to be a ceramic capacitor. And if I'm tight on space, you don't need both. It's ceramic and surface mount. So if I was super tight on space, I'd do the 10 ceramic, but not have the second one. No big deal. So always read your data sheets, the text. If the original designer would have done that, perhaps we wouldn't have the problems that we have today. Over a decade later, very annoying, but these things happen. I do also want to mention that this day and age, a lot of corporations have skeleton crews for everything. So even when you do a design review, don't count on other people catching this type of stuff. They're just as busy, if not busier than you are. They probably will not go into a data sheet on this level just for a design review. So be aware of that. So if you're the one doing the design, you need to be doing most of the legwork yourself. Don't plan on others to save you. Okay, I do want to mention something else though. This is kind of your bare minimum, read the text. Now I want to go a little bit more expert level type thing. So the rest here is fine, but we're doing a 7-segment display. So maximum recommended segment current is 40 milliamp. I'm like, that's kind of a lot. All right. If it was just 40, I'd say 10 is enough. But if you keep going up in this data sheet right here, so I want to look at digit drive sync current, 320 milliamps. Absolute maximum rating 500, but no. If I'm given both absolute max and in the electrical characteristics, I use this. Now, okay, so now we have a max current. What we will not have based on datasheet alone is DIDT. So basically, how are we using this 7-segment display here? Are we going to have them all off and then they're going to be all on and then we do other stuff? So I want to know how it works. That way I can get an idea of DIDT. So if it's a reasonably small DIDT, okay, that 10 microfarad might work. But if I'm going this high regularly, then 10 might not be enough. So it is not just enough to read a data sheet and do a data sheet. That'll get you there most of the time. But to be on a more expert level, you need to know how the circuit works. That way, some of these more subtle things right here, you can plan for them ahead. So, awesome. This shows everything I wanted to show. Great data sheet to use as an example. So please, if you have any questions, leave a comment, anything like that, like the video. So thank you for your time. Goodbye.